A chord is a segment whose endpoints are points on the circle. So a diameter is a chord, but a chord isn't necessarily a diameter. It does, but that is a chord. So a diameter is a chord, but a chord doesn't have to be a diameter. A chord is anything where the two endpoints, Stasia, are on the circle. The diameter just happens to go through the center as well. Yes.
Does the chord have to be in the circle, or can it be out?
It has to be in the circle. Endpoints have to be on the circle. Okay, a secant is a line that intersects the circle at 2 points. So a secant is a line. It just has to cross the circle twice. Anywhere on there that it crosses twice. So you get that a chord is a segment and a secant is a line. A chord stops at 2 points, secant goes all the way through. Okay, tangent is a line in a plane of a circle that intersects the circle at exactly 1 point. A common tangent is a line that is tangent to 2 or more circles. So there's a tangent, it touches it just at one place. A common tangent is if you have 2 circles, if it touches both those circles. Just pretend it only touches that circle at one spot. Because that was bad drawing on my part. If a line is tangent to a circle, then it is perpendicular to the radius. So if we have a point, if a line is tangent to a circle, so that means it goes through 1 point, it must be perpendicular to the radius, always. It means it must form a 90-degree angle. If 2 segments from the same exterior point are tangent to a circle, then they are congruent. So if we have a point and we have 2 circles, 2 lines that are tangent to the same circle, these 2 must be congruent. Yep. Okay. If a line is tangent to a circle, it must be perpendicular to a radius. Okay? If we have 2 segments from the same exterior point that are tangent to the circle, so this, here I'll do it. This segment is from here to here, it hits the circle at 1 point. This segment hits this point, tangent to the circle at this point. Those 2 segments are congruent, always. And I can prove the theorem to you, but it'll take a long time, and I don't think you're very interested. Do we just believe that the theorem is true?
Yes. I concur.
All right. Now, all we're going to do for A through H is define what they are. What is F?
Secant.
Yeah. No, it's not.
It is letter F. Not 9. Just letter F. That means a point. So it's the point of tangency.
Oh.
Is the point of tangency?
I'm not sure why we're talking while I'm talking, but I find it more than a little bit annoying. If you could stop, I'd really appreciate
What's
it.
that word after point of?
Point of tangency.
Can we just put POT?
Yes. F to E.
Common tangent.
Common tangent. Is POT some cool hip thing that I know about?
Oh, I
I don't want to know, and let's not have it on record. Okay,
I'll tell you after.
good. All right, H to G is a
Radius.
radius. Told you guys, I'm so old now, I don't know these things anymore. D to B.
Chord.
Now, yes, because it doesn't have the little arrows at the end, so we know it is a chord. Again, I'm not sure while I'm talking. If you have a question, I'd love to help you with it, so please raise your hand and ask. Otherwise, if you could not talk.
Oh, so D to B, when it says D to B, it doesn't have the arrows at the end, so it's not.
Right, right.
It's a segment.
So, C.
Point of.
Center.
Yes. That
Just call it the center. Center of the circle. We could say center of circle C. That's shorthand for circle C. All right, BE is a segment, so it is 2 things. It is a diameter and a chord. It is a chord that is a special chord because it is also a diameter. Okay. G, line D to B. has to be a line. Chord has to be a segment. Line AG, common tangent. Okay, I want to talk about one more thing before you turn that page.
Is there a difference between a common tangent and a tangent line?
Yes, a tangent line only goes by one circle. Common tangent goes by two.
So if it only goes by, like, if it only lays on one circle, it's just a tangent.
Okay. What is the difference between line AG and line EF? They're both common tangents. AG is an exterior common tangent
Because it's outside.
because it's outside the circles. EF would be a
Interior.
interior common tangent because it goes between.
Do we have to say that?
You will eventually. So I just want to bring it up now. All right, let's turn it over. Ceiling must be shaking a lot. Do you guys notice how my screen is shaking?
Yeah.
Sometimes.
Really weird.
Maybe somebody on the roof.
There's somebody on the roof right now. It's so windy outside. Okay. The diameter of a circle is given. Find the radius. So A is,
6.5.
yeah. B,
4.
make sure you put meters or inches or whatever. D is,
6.3.
and D, we'll say 6 feet 3 inches.
Wasn't, yeah, 6.3.
How do I know all of these? Because the diameter is what of a radius? Does everybody get that?
Yeah.
I heard some people being like, how does Chris know?
You mean a radius?
Yes.
You mean a radius is half
A radius is half a diameter.
You said diameter is half a radius.
That was crazy. A radius is half of a diameter. So if I know the radius, how am I going to figure out the diameter?
Just times it.
I was watching.
Everybody hear that? Okay. All right, so let's look at what's A? 22 what? There we go. What's B?
63 feet.
What's C?
22.5 feet.
And what's R?
11 feet 4 inches.
Because 5 feet and 5 feet makes 10, right? Okay, 7 and 7 makes 14 inches. So it should be 2 inches, not 4.
I did on my calculator, it's 5.7. That was 2. I got 11.4.
Because it goes up to. Wait, how do you get 11? 12?
Yeah.
Okay, if we have 10 feet, 14 inches, how many inches is in a foot? So I move up to 1 more foot, and how much do I have left over? 2 inches. Does that make sense? Wanted to make sure you get that before I move on. All right, now we're going to talk about the different kinds of common tangents. Hi. How many common tangents does the circle have, and can we classify them as exterior or interior? Okay, how many tangents can we have in this? I can have one right here.
2.
So that's 1, and I can have one right.
2.
How many do I have?
2.
Are they internal or external?
I can't.
Can I have an internal?
No.
No. How many tangents can I have for this circle?
1.
Let's look at it again.
2.
How many common tangents?
None. I have none.
Because a tangent cannot go through the circle. It can only hit it in one spot. How many tangents can I have for this one? I can have 1. Oh.
Oh, that's smart.
Everybody look to the side.
Whoa. There you go.
Okay, that was exciting. All right. I've never done that before. I don't know how I did it. Okay, how many tangents can I make for this one? I can make 1,
3.
2, and 3.
2
So 2 external, 1 internal. We okay with this so far? Anybody need to stop me? Okay. How many can we make for this one? We can make 1,
2.
2. Who said 4?
4.
You are correct.
Back.
I have 2 external and 2 internal. How many can I have for this one?
0.
1. 1 external. How many can I have for this one? All right. I'm excited. All right, let's do A and B for example 5. And I promise we will not do all the problems in example 6. There's a lot. But I want to do them. All right, we know this is 17, this is 12, and this is 8. How do I know if A to B is tangent? What do I know about tangent lines? They are what? What does theorem 10.1 say?
They're perpendicular to the
Radius.
Strong and appreciate
Okay, how could I tell from these numbers that it is perpendicular to the radius? What is that happy theorem I have of a triangle? No.
Yeah, I was about to say. Or one that I forgot.
Starts with a P.
That's
The Pythagorean theorem. Okay.
Oh, I don't want to do that one.
17 squared equals 8 squared plus 12 squared. If this is true, I know this is a 90-degree angle. So I don't have a calculator, so I need some help. What is 17 squared?
289.
289 equals 64 plus 144. 4 and 4 makes 8.
That's not going to do it.
10.
208.
208 does not equal 289. So AB, not a tangent.
Just put no.
Sure. Alright. So we've got 7, 24, and 25. So what do? I want to prove if it's a tangent, so I go
It is.
it is? Yes, tangent. Anybody doubts Chris? Stick with your calculator and see if it's true. Last ones, guys. We're almost done. We're almost done. We're not going to do all of these.
They're going to equal each other, so it's 70.
Okay. So, if two tangents meet at an exterior point, we know that they're what? Yes. So, all you're doing is going 6x minus 3 equals 5x plus 7, correct?
X equals 10.
So, I'm going to subtract 5x. I get x minus 3 equals 7. So, x equals 10. What if I wanted to know what each of these were? What would I do?
Plug it back in.
Plug it back in. I get 60 minus 3 is 57. And 10 minus 5 is 50 plus 7 is 57. They're equal to each other. I did it right. Yay.
X equals 4.
Okay. Theorem 10.2 says if two tangent lines, which AB and AD are both tangent lines, meet at an external point, that they have to be equal to each other. So all I did was set those two equal to each other. I subtracted 5x from both sides. I got x minus 3 equals 7. Okay? I added 3 to both sides. I got x equals 10. Then I wanted to plug it back in because I wanted to know what the length of AB and AD were. 10 times 6 minus 3 is 7.
Do we have to
10
find
times 5 plus 7 is 57. So they're equal. They're both equal. Okay,
X is 5 for D.
I'm going to do D. Because D is not a happy. D. We've got x squared minus 1 equal, is 24. So we set them equal to each other.
Add 1.
You add them. X squared equals 25. And then you do what?
Square root.
So x equals,
5.
or what else could x equal?
Negative.
Negative 5, but are we going to have a negative answer for these? Negative 5 times negative 5. All right, let's do E. And then we'll be done.
E. You mean F? Wait, we slide that a
E.
little bit. Slide that. You put A, B, C, D.
Oh, I thought it was C. Never mind. I thought it was like CF. What?
I sometimes do that though, Chris, so I wouldn't put that. All right. Jake, are you good?
Yeah.
E. All right, who remembers how to factor? Okay, well, let's go over it since I saw no one raise their hand. All right. Okay, you ready?
Yes.
These two are what to each other? Okay. Everybody's okay with them being congruent. I'm on E. Okay. So, I can't subtract and then take the square root of anything. It's not going to work because I've got multiple x's. So what I'm going